Hey guys, today topic is renal tubular acidosis. So before going into the details of the renal tubular acidosis, I want you guys to familiar with the two terminologies. So then you better understand the concept of the renal tubular acidosis. So first terminology is the acidemia. So what does the acidemia mean? Acidemia mean low pH of the blood. The state of the low pH of the blood, that is called acidemia. Then what is acidosis? Acidosis is the condition in which your body fluids are becoming acidic. So these are the two terminologies, acidemia and acidosis. Then come to the next topic, which is renal tubular acidosis, our topic. So what is renal tubular acidosis? It is the defect in the renal acidification system. So it is the defect in the renal acidification of the system. Now we have different types. So there are three main types of the renal tubular acidosis. So what are those types? Coming over here, that is renal tubular acidosis type 1. Let me move my cursor with you. So renal tubular acidosis type 1. Then you have renal tubular acidosis type 2, and then you have renal tubular acidosis type 4, right? There is no renal tubular acidosis type 3. So keep in mind. So you have 1, 2, and 4. So before going into the details, we need to know which RTA is occurring in which part of the nephron. That is very important. So here is the picture of the nephron. So let me get my cursor. So this is your glomerulus. Along with this is afferent, efferent arteriole. Here I draw the Bowman capsule. Bowman space. So this is glomerulus and this is your Bowman space. Now this is proximal convoluted tubule. This is descending limb of the nephron. I'm not getting into details of the thin and the thick ascending limb. Over here, just you have to remember that this is the descending limb of the nephron. The next is you have DCT, and the last part is the collecting duct, and this is where you have collection of the urine, right? So renal tubular acidosis type 2 is occurring in the proximal convoluted tubule over here. RTA1 is occurring in the DCT, while RTA type 4 is occurring in your collecting ducts. That's why over here I have written already that you are dealing with the type 1 in this lecture. So this is occurring in the DCT, right? So now I need to tell you what is normally happen, then what is the defect. So normally what is happen that hydrogen ions are excreted into the tubular lumen, right? Hydrogen ions are normally excreted into the tubular lumen. So what is happening? So what is the defect in the RTA? This hydrogen ion, right? They are not excreted into the tubular lumen, right? So I will go into detail of this one, but before going into that, I want to show you what are the benefits of this hydrogen when it get into the tubular lumen. So over here I draw a picture. So this side picture is where I show you this is the peritubular capillaries. These brown ones I draw for you the epithelial cells. In between I show you the tubular lumen, right? I get a cross section of this area over here. Now you can see what is happening. So this hydrogen ion is secreted. I am starting from here. So this hydrogen ion is secreted into the tubular lumen, right? So what happened? This hydrogen ion will combine with the bicarbonate ion. So bicarbonate ion, it is coming from above. So this bicarbonate ion combined with this hydrogen to form H2CO3 under the influence of enzyme carbonic anhydrase. And then H2CO3 is dissociated into H2O and the carbon dioxide. This carbon dioxide get into your epithelial cell. It again combined with water inside the epithelial cells to form carbonic acid, and again this carbonic acid is dissociated into hydrogen and bicarbonate ion. So when you are secreted one hydrogen ion into the tubular lumen, at the same time one bicarbonate ion is reabsorbed back into the blood with the exchange of chloride into the cell. So this is the normal pathway. Now what is happening when this hydrogen is not secreted into the tubular lumen? Over here I show the ATPase pump. So when this hydrogen is not secreted into the tubular lumen, there is no hydrogen available to combine with bicarbonate, right? So what is happening? This bicarbonate is running down into your tubular lumen and it makes your urine alkaline. That is pH greater than 5.5, right? This is what happened. Now there are some consequences of this RTA type 1. So what are the consequences? Let me repeat, let me explain once again. So one is, number one, you are not secreted hydrogen into the tubular lumen. This is not happening. So what is happening? What is happening into your body? You think when you're retaining hydrogen inside your blood, what would be happen? You have metabolic acidosis. You're right. You have metabolic acidosis. And when you have a lot of bicarbonate over here, which I told you in the previous slide, you will have alkaline urine, right? Alkaline urine. That is pH is greater than 5.5. You have metabolic acidosis, alkaline urine. So when you are not secreted hydrogen into the tubular lumen, the compensatory mechanism is happening in which you are secreted this one. So you are secreted potassium ion into the tubular lumen. So when you are secreted potassium ion into the tubular lumen, back in the blood you have hypokalemia. Hypokalemia means you have decreased potassium in your blood. So alkaline urine, metabolic acidosis and hypokalemia. So what is happening with the metabolic acidosis and hypokalemia? So metabolic acidosis and hypokalemia lead to increased citrate reabsorption into your citrate reabsorption from the lumen back into the blood, right? I come back into the advantages of citrate being in the lumen. So metabolic acidosis, hypokalemia lead to the increased citrate reabsorption into the blood. And the fourth point is, this is your third point. The fourth point is that metabolic acidosis causes decreased calcium reabsorption back into the blood. So your calcium will be stay here into your tubular lumen, right? So what is happening normally what is happening, if you have excess of calcium in the tubular lumen, it combined with the citrate and it is secreted. Calcium and citrate complex is formed that is excreted into your urine, right? But in this case, as I told you that the metabolic acidosis causes increased citrate reabsorption, there is no citrate available in the tubular lumen for the calcium to combine, right? So what is happening? This calcium combined with the oxalate in the urine and form the stone, or this excess calcium is precipitate, result in the kidney stones. So in case of renal tubular acidosis type 1, which is happening in the distal convoluted tubule, you have defect in the hydrogen ion excretion into the tubular lumen that leads to the metabolic acidosis. Then you have increased bicarbonate into the urine, leads to the alkalinity of the urine, pH greater than 5.5. For the compensation, potassium ions are secreted into the tubular lumen, which result in hypokalemia. Both hypokalemia and metabolic acidosis lead to increased citrate reabsorption into the blood. And fourth point is metabolic acidosis causes decreased reabsorption of the calcium. Calcium stay in the gut, lead to the kidney stones. So in renal tubular acidosis type 1, you have metabolic acidosis, alkaline urine, hypokalemia, and then kidney stones. Hope this helps you. Then wait for my next topic, which is RTA2, and then I will explain RTA4. Thank you so much, guys. Thank you.